So what we do is we have what's called direct variation and inverse variation. Direct variation was probably something you guys learned when you had what we call this, like the precursor to finding what's called slope.
Is that k to x?
Yeah, it's what happens here is that you're going to deal with this value of k, where k is some constant. We call it the constant of variation. Okay. And what we would do is we'd say that x and y vary directly, or x and y vary inversely. That's what we're looking at here today. It's either going to be a direct variation, inverse variation, or in a little bit here we're going to talk about what's called joint variation, where you're going to have multiple things going on. Once you get the lingo down for it and how these equations write themselves out, it's ridiculously simple to work with. I mean, really, really very simple to work with. Like I said, direct variation you guys probably saw when you first learned about slope in your algebra class. Maybe.
A little bit. I think I remember.
It's something that they started to not do as much as they used to. So that's kind of what, if you're not sure about it, it's not that big of a deal. But this value of k, ooh, that is an awful k there.
Your time to check.
Yeah, I'll get there. Hi. There you are. All right, so let me show you guys how this stuff's going to look. The way that we're going to work with these things is the way we say it, if we're talking about inverse variation, we'll say y varies inversely with x. When we say y varies inversely with x, that means y equals k divided by x. If we say y varies directly with x, it means y equals k times x. All right, that's the
Inverse.
Yep, that's basically it. So if it's y varies directly with x, we just say y equals k times x. Excuse me. How we are able to set these things up is basically we're going to try and take equations, get y by itself to see if it's going to be a direct variation or an inverse variation. And getting y by itself more often than not with some of these things we're going to look at today, it's maybe one or two steps. It shouldn't be anything crazy whatsoever. So we classify these things by what we're given as far as an equation is. We rewrite the equation to get y by itself, and then we're able to tell what kind of variation we'll have. For example, if I happen to have y, okay, look at me. Every once in a while I try to throw something at you that's not like crazy. So if I have y divided by 5 equals x, I want to get y by itself. So how do you get y by itself?
Times by 5.
Multiply by 5. So you get y equals.
5x.
So do you think that's direct or inverse variation?
That's
Direct.
It's direct variation. With a k value of?
5.
And like I said earlier, a lot of this stuff is kind of like the precursor to slope. When you guys start talking about direct variation. What? Can I get y by itself now? It kind of is, isn't it? So is there a variation here?
No.
No, there is not. Direct variation is when you're multiplying something to x. Inverse variation is when you're dividing. It has absolutely nothing to do with addition or subtraction. So there's no variation here. And then lastly, oops. X times y equals 4. Bless you. It's inverse because what do you wind up
You
with?
get y equals 4 over x.
Very good. And that's what inverse would look like.
So what would happen if you got x over 4 plus it would be
If it was x over 4, it would be direct variation with a k value of 1/4.
Alright.
See what I said? Does that make sense?
Yeah.
Yeah. So there's a lot of little nuances that go through with some of these things. Okay, there's a lot of little nuances that'll happen. All right. So what'll happen also is that we're trying to decide. Oh, I did that. What kind of a relationship will they have when we look at a table? This kind of looks weird, but when we're talking about direct and inverse variations, either y equals k times x or y equals k over x. So what we're looking at here is, think of this as an x and a y, the w and the h, as an x and a y. Is there some constant relationship between the two happening? Think of this as x and y. What we do here is we substitute in those values for x and y, and to see if this value of k shows up each time as the same value. Okay. So, probably get a little heavy in here, sorry. It's a high-pitched sound from the Anyway, so take a look at what happens. Does 9 equal k divided by 2? Does 4.5 equal k divided by 4? Does 3 equal k divided by 6? And so on and so on. What we're trying to do here is see if is there a constant value that's being used each time. So what I'm doing is I'm going to solve each one of those one-step equations for k to see if it's the same thing. So how do you solve for k when 9 equals k over 2? You multiply. So here k is going to equal what?
18.
18. K is going to equal? Well, do you know how to do this in your head? 4.5 times 4?
18.
Double 4.5, what do you get? Double it again. And what were the other ones we had? 8 and 2 1/4? I might sense a pattern as well, and just going to say it's probably 18.
Yeah.
So do we even need to bother if checking to see if it's going to be a direct variation then? Obviously we found out that this is an inverse variation with a k value of 18. So what we would do is then, this is an inverse variation, and the equation would be y equals 18 over x. And that's what it would look like. Just taking data from the table and trying to see what model, if you will, does it fall into. Bless you. Hoping that that's not very scary. Yes, ma'am.
So if you check both of them, you will work on
And usually what happens a lot of times is that once you check the first one, the second one, if we did 9k over 2, the next one it was 18, the next one was 15, I would just double check, make sure I didn't write something down wrong, and then I would check the multiplication version of it. You'll get different numbers right off the bat, and you'll notice it's not going to work. Same idea. Call it x and y. I don't know why I use r and t. That's kind of weird.
So if you have one different number, if you try one equation, you automatically scrap it and let it know.
Yeah. And yeah. And sometimes they might hide that on you. Could be the last one. So go through 4 of them, then say, oh, it works, and then all of a sudden you can check that 5th one in.
So you should always do all of them.
Yeah, it doesn't hurt. I mean, after a while, if we're going to check direct variation, we know that's got to be, I'm sorry, inverse. We check inverse, it's y equals k over x. Basically what I'm checking here is if I multiply those two numbers together, am I getting the same thing each time? If I'm checking direct, I'm dividing them to see if I get the same thing each time. That's really all I'm doing. Right? So as you start to check through these things, let's see, I get 300, 300, 300, 300, and 300. Yeah. Because if you start thinking about it, if it's going to be an inverse variation, if I solve for y, or excuse me, solve for k, x times y has to equal k.
Okay.
See what I'm doing? I'm shortcutting it through. Just grab it. You should cut it. And if I do it the other way, I'm just dividing it. All right. It's just a nice little shortcut if you pick up on it. So in this case here, what's our value of k? 300. I know it's a bore. I'm sorry. Yeah. I don't think we need to do that one. We're fine. So the other thing that we're going to do with this is, yes, ma'am. Y equals 300 over x. We found that value of k was constant. It was always the same thing. So that's your constant. And we knew that was inverse because if we take 300 divided by x, it's always going to give us that y value. Yes. What's wrong? You make fun of my tie? So here's what happens when we write out the equation. This is more along the lines of what you're going to see is that variables x and y vary inversely when y equals 8, or excuse me, and y equals 8 when x equals 3. So it says they vary inversely. As soon as you see that it says varies inversely, that means it's y equals k over x. That's what the inverse variation generic equation looks like. And then they give you y and x. So what do you think you do with y and x? Are you doing electrical work?
No.
Substitute. So to write 8 equals k over 3. Therefore, what is the value of k? 24. Good. Which means that the generic equation would look like y equals 24 over x. You're taking the information that they gave you. They said something varies inversely, so you know it's got to be y equals k over x. You take that one step further, you substitute in, you find the value of k, and then you rewrite the generic. Because now it asks you to figure out what's y when x is negative 4. Very good. Then you're just going to read back and substitute it again. There's usually 2 parts to these types of problems. They're going to give you something like that, and you have to resubstitute. All right. Good morning again. Yes. Done. It just asks you what's y when x is negative 4. You had to figure out what the value of k was in order to figure out what y was. Inverse variation stuff, there's really not a lot of craziness here. What this is trying to get us ready to do is to graph inverse relations where they're going to do stuff like this, that kind of thing. So try this one. X and y vary inversely, same basic setup. When x is 1/2 and y is 10, what's y when x is 2? So we know they vary inversely. When something varies inversely, so we don't need to worry about hypotenuse leg. So you started out with the generic. Y equals k over x. Substitute in. And solve for k. You should get 20.
I got
20 divided by 100.
That's
Five.
I was just checking to see if you were paying attention.
I have
Yes.
I have
I was like,
mine.
no, what's
didn't
the-
done
Oh,
yet.
you guys just need 20?
I got it right. It's okay. I got it right.
I'm sorry.
Too.
Uh-huh.
That's like half.
I got hit with a paintball yesterday. So what's y when x is 2?
When we use this number here.
Okay. What's that?
When we use this number.
I didn't hear you.
Never mind.
No, you're just
He
mumbling.
said mixed numbers. What do you
Mixed
use
up.
it?
Oh, just use the top every fraction. 5 halves is all you have to do. That's fine. Okay. Okay. Joint variation. So when you're combining more than one thing. Joint variation is when it says something varies jointly. That means there's more than one thing being multiplied together. So if x and y vary joint, or excuse me, let me reread this here, how they say it. For instance, if z equals kx times y, then z varies jointly with x and y. As soon as you see the word varies jointly, that means you're multiplying more than one thing together. Okay. Varies jointly stands for multiplying more than one thing. So z varies jointly with x and y. That just means z equals k times x times y. This is more of the three-dimensional plane stuff that you'll get that for like an actual use of this type of a problem. But we don't do anything with 3 dimensions anymore, so. Yes. We used to have to graph in 3 dimensions. I think we've done that in a few years. Yes, ma'am. What do you mean? Like solve for a direct variation? Yes, if it says direct, you do the same thing. It just would be with the direct variation as opposed to the inverse. That's all. You can do that with any one of these. We actually do that with the jointly variation as well. We just have an extra thing to substitute in. That's all. It's pretty straightforward. Solve for k and then free substitute. So let me show you what happens here when you have these different types of ways of writing these things out. For example, we know y varies directly with x. That's y equals k times x. Y varies inversely. Y equals k over x. And then the last few are the weirder ones. And you'll start to get a grasp of what it looks like. Z varies jointly. Z equals k times x times y. Then you have the next one. Y varies inversely with the square of x.
What?
Y varies inversely with the square of x. Well, basically, think of it this way. We know there's an inverse variation, so it's got to be y equals k divided by something. Well, what are you dividing it by? X squared, the square of x. Okay. So some of these things can be wordy, if you will, as you start to read through them. So let's see. Z varies directly with y and inversely with x. That's another pattern that can occur, where you can have a direct variation with one and inverse variation with the other. When you have something like that, that just means one of them's being multiplied, the other one's being divided. Inverse means division, like you were saying a second ago, Paul, and direct means multiplication. The square means squares. If it said cube, you'd put it to the what power? Third power. Little things like that. There's only so many of these, and I don't want to say them all because there's a couple that you're going to do for homework. I know. It's scary. I think you'll be all right. Oh, just in case you guys were all worried, I already opened up the Chapter 9 tab on the website, so this is all up there. I know you were really worried. I could sense it. What about this? Y varies jointly with z and the square root of x. Y varies jointly with z and the square root of x.
Wait, and the square root of x.
And square root of x.
Oh, I didn't.
Y,
Well, I can write that down. Okay. Jointly, that means you have z.
Wait, the x squared.
y varies jointly with z and the square root of x.
Okay.
Square root.
Oh,
Kz root x. So y equals kz root x.
That's all you want?
That's all you gotta do. Like I said, guys, it's gonna sound a lot harder than it really is. Just remember when you have joint variation, you're just multiplying more than one thing together. And that's really all there is to it. Yes, ma'am? Yeah, you're just multiplying k. If it says jointly, you're just multiplying it all through. If it says jointly with z and x and inversely with r, you just put it over r. Anytime you hear the word inverse, make it a fraction. Okay? Yeah, we'll just do this. All right, I don't think there's, I don't know, let me double check, is that what I want? Yeah. Do these, please. What's up?
Classics, like sometimes I'm just
Because I'm an idiot.
second
Remember, y equals k over x.
That's like
So that means y times x is k. I accidentally. I divided by that. I forgot to multiply it. That's all. Monday, I made a mistake. I had a welt right here. That's why I've been in pain.
I have this freestyle.